Our past lesson is about arithmetic sequence. We can able to tell that a sequence is an arithmetic if it has a common difference. This time, we're going to find the nth term of an arithmetic sequence. Let's try to have this example. Darlene wanted to buy April a gift for her birthday. She saved 20 pesos on the first day, 22 pesos on the second day, 24 pesos on the third, and so on and so forth. Make a sequence representing her daily savings until the 10th day. So it means we need to list down the sequence or the money that she need to save for April's birthday. Let's have the sequence 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. What have you noticed about this sequence? Yes, it has a common difference. If we're going to subtract 20 from 22, that is equal to 2. Subtract 22 from 24, that is also 2. Same with 24 and 26, and so on and so forth. So, what kind of sequence is it? Yes, this is an arithmetic sequence. Based on the sequence, what is Darlene's savings on the 10th day? So just by simply counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it means Darlene's savings on 10th day is 38. But how about if you are asked to find her savings on the 30th day or in 50th day? It's very difficult or complicated if you're going to list down all the numbers and count them all. So what are we going to do? Let's try to observe an easier way on how to solve the problems of Darlene. Based on this table, this is her savings for the first 5 days. Let's say that her saving on her first day is 20. On second day is 22. So we just simply multiply the common difference by 1. So that is 20 plus 1 times 2 is 2. So that is equal to 22. On the third day, we're just going to multiply the common difference by 2. So that is 2 times 2, which is 4. So 4 plus 20 is 24. On the fourth day, we're going to multiply again the common difference by 3 this time. So 3 times 2, that is 6, plus 20, that is 26. On the fifth day, we're going to multiply the common difference by 4. So that is 8, and 8 plus 20, that is equal to 28. So what have you noticed about this table? Is there any pattern that you observe from this table or from this listing? Yes. On here, 20 is a sub 1. So it means we need a sub 1. And here, 2 is the common difference. But 1, 2, 3, and 4 is not quite the same with the number of term. It is 1 less or mas mababa ng isa yung pinamumultiply natin sa common difference based on the number of terms. So, paano kaya? Ano kaya ang mangyayari? So, it means, based dun sa observation natin kanina, sa day 1, meron lang tayong 20 or yung first term natin. Sa day 2, yung first term plus 2 or yung a sub 1 plus d or yung common difference. Sa day 3, minultiply na natin yung common difference sa 2. So, 2 times 2, that is 4. Or, nag-multiply na tayo ng 2 sa common difference. Pero, same, nandiyan pa rin yung a sub 1. Sa 4th day, nag-multiply na tayo ng 3 sa common difference at inad sa first term, or that is a sub 1 plus 3d. At sa 5th day, nag-multiply na tayo ng 4 sa 2 or sa common difference, kaya meron tayong a sub 1 plus, kaya meron tayong a sub 1 plus 4d. That is on the 5th day. So, pansinin natin, yung a sub 1 consistent na nandyan. Tapos yung d natin, mas mababa ng isa kesa dun sa number of terms natin. Dito, wala pang d. Dito, 1. Sa 3rd term, 2. Sa 4th term, 3. Sa 5th term ay 4. So, ibig sabihin, nagbabawas lang tayo ng isa. Sa madaling sabi, pwede na tayo ngayon mag-create ng formula or n-term formula based on sa observation natin kanina. Ito ang magiging formula natin. A sub n or the nth term is equal to a sub 1, yung consistent na nakikita natin kanina, plus n minus 1 times d. Kasi nga, mas mababa ng isa yung i-multiply sa common difference based dun sa number of term na n. Wherein, yung a sub n natin is the nth term, ang ating a sub 1 ay first term, ang d naman ang ating common difference, at ang n ay number of terms o yan yung bilang ng terms na hinahanap natin. Let us try to solve our problem a while ago. The Darlene savings on her 30th day. Or, we need to find the 30th term of the sequence. First, we need to identify the given. We need to find a sub n or the 30th term. Our a sub 1 is 20 because 20 is our first term. And d is 2. To get 2, we're just going to subtract a sub 2 minus a sub 1, or a sub 3 minus a sub 2. And of course, the value of n is 30 because we need to find the 30th term. With the use of the nth term formula, or a sub 1 is equal to a sub 1 plus n minus 1 multiplied by the common difference, we can solve the problem easily. First, we need to substitute. N is equal to 30, a sub 1 is 20, again n is 30, and our d or common difference is 2. By simplifying, 30 minus 1 is equal to 29. Then bring down 20, same with 2. And 29 times 2, that is equal to 58. And 58 plus 20, that is equal to 78. So it means the 30th day savings of Darlene is 78. Now let's try to solve the next question. The 50th day savings of Darlene to buy April a birthday gift. So again, we need to identify the given. This time, we're going to find again the a sub n or the 50th term. And of course, our first term is 20. And d is equal to 2, or the common difference is 2, and this time the value of n is 50. So by means of using the nth term formula, or a sub n equals a sub 1 plus n minus 1 times d, we can easily solve the problem. First, we need to substitute again. a sub 50 is the missing. So substitute a sub 1 to 20, n is 50, and d is 2. By simplifying 50 minus 1, that is equal to 49. And 49 times 2, that is equal to 98. And 98 plus 20, that is equal to 118. So it means Darlan's savings on the 50th day is 118. So with this formula, we can easily solve an n term that is missing. But in some cases, a sub n is not just the only one that is missing. Sometimes, a sub 1 is also missing. Or d, sometimes it is n. So based here, we have some formulas that we can able to use. If a sub n is missing, we need to use the nth term formula, or the a sub n equals a sub 1 plus n minus 1 times d. If a sub 1 or first term is missing, we need to use a sub 1 equals a sub n minus n minus 1 times d. If d is missing, we need to use d is equal to a sub n minus a sub 1 all over n minus 1. If n is missing, we need to use n is equal to a sub n minus a sub 1 all over d plus 1. So take note of this formula because we're going to use this on our next examples. Let's try to have this example. What is the 10th term of the arithmetic sequence 5, 14, 23, 32, and so on? So first, we need to identify the given. A sub n is missing, or we need to find the 10th term of the sequence, or the a sub 10. Then next, a sub 1 is 5, or the first term. And d is equal to 9. We can subtract the second term to first term, or first term from the second term. That is 14 minus 5 is equal to 9. And n is equal to 10 since we need to find the 10th term. By using the nth term formula, or a sub n is equal to a sub 1 plus n minus 1 times d, we can easily solve this problem because a sub n is missing. Then next, we need to substitute the given. A sub 1 is 5, n is 10, and d is 9. By simplifying, 10 minus 1 is 9, and 9 times 9, that is equal to 81, and 81 plus the first term, or 5, that is equal to 86. So it means the 10th term of this sequence is equal to 86. Let's have the next example. What is the 8th term in the arithmetic sequence? Negative 3 square root of 5, negative square root of 5, square root of 5, 3 square root of 5, and so on. So first, we need to identify the missing, or the given. A sub n is missing, or we need to find the 8th term, or the a sub n of the sequence. Next, a sub 1 is the first term, or negative 3 square root of 5. D is 2 square root of 5 by simply subtracting the second term to the first term. That is negative square root of 5 minus 3 square root of 5, that is equal to 2 square root of 5. Remember, if we're going to subtract radicals, we need to check if the radicand are the same and just subtract the coefficient of the radicand. So that is negative 1 minus 3 following the rule of integer, that is equal to 2. And of course, the value of n is 8 because we need to find the 8th term. So since a sub n is missing, we need to use again the nth term formula, or a sub n is equal to a sub 1 plus n minus 1 times d. By simply substituting, a sub 1 is negative 3 square root of 5, n is 8, and d is 2 square root of 5. By simplifying, 8 minus 1 is 7, and this 7 will be multiplied by 2 square root of 5. Here again, we need to multiply the coefficient to 7. So it means that is equal to 14, then copy the radicand, which is square root of 5. And then this time we're going to simplify. So if we're going to add radicands, or radicals rather, we're just going to subtract again the coefficient, but make sure that the radicand are the same. So that is negative 3 plus 14 following the rule of integer, that is equal to 11 square root of 5. So it means our 8th term is 11 square root of 5. Next, let's have our third example. In the sequence y, x, 2x minus y, and so on, what is the 10th term of the sequence? So first, we need to identify the given. A sub n is again the missing because we need to find the 10th term of the sequence. Next, a sub 1 is y, the first term of the sequence. Then d, that is x minus y, that is second term minus the first term. And n is equal to 10 since the missing is the 10th term. So again, with the use of the nth term formula, or a sub n is equal to a sub 1 plus n minus 1 times d, we can solve the 10th term. First, we need to substitute. A sub 1 is y, n is 10, and d is x minus y. So by simplifying, 10 minus 1 is equal to 9, and we're going to distribute 9 to x and 9 to negative y, that is equal to 9x minus 9y, or 9 times x is 9x, and 9 times negative y is negative 9y. Then bring down y. Then this time we're going to combine like term, which is y and negative 9y. That is equal to negative 8y, and bring down 9x. So it means our 10th term, or ang a sub 10 natin, is 9x minus 8y. Let's have our fourth example. What is the common difference of an arithmetic sequence if a sub 1 is 3, a sub 35 is 173, and n is equal to 35? Again, we need to identify the given. Our first given is a sub n, which is 173, or our a sub 35, which is 173. A sub 1 is 3, or ang first term natin ay 3. Then next, we need to find the common difference, or missing ang ating common difference. Ayan siya. And of course, the last given is n, which is equal to 35. So since d is the missing, we're going to use the formula in finding the d, which is equal to a sub n minus a sub 1 all over n minus 1. So by simply substituting, yung a sub n natin or yung a sub 35 which is 173, substitute it here, and a sub 1 which is 3, and then n is 35 minus 1. So 173 minus 3, that is equal to 173, and 35 minus 1 is 34. And 170 divided by 34, that is equal to 5. So it means our common difference is simply 5. Let's have our fifth example. If the 21st term of the arithmetic sequence and the third term is 107 and 17 respectively, find the first term. So based here, D is not given. We only have two terms that are given, which is 21st and the third term, wherein these terms are not consecutive. So based on our last example, we need to use the formula for D, which is a sub n minus a sub k all over n minus k. Yung value ng n dito is yung last term na nabanggit, which is 21. And ang value ng k dito ay yung maliit na term na nabanggit o yung naunang term na nabanggit, which is 3. Same here. So by substituting, a sub n is 107 and a sub k is 17 and n is 21 since the given is 21st term, or 107 is the 21st term, and yung k natin, which is 3, dahil ang given ay third term. And then simplify 107 minus 17, that is 90, and 21 minus 3 is 18, and divide 90 divided by 18, that is equal to 5. So here the value of D is equal to 5. Then next, another given is a sub n, which is 107, and n is equal to 21. Then of course, we need to find the first term, or a sub 1. So with the use of the formula, a sub 1 is equal to a sub n minus n minus 1 times D, we can easily solve this problem. Next, we need to substitute. A sub n is 107 minus n is equal to 21 minus 1, then D is equal to 5. So by simplifying 21 minus 5, that is equal to 20. And since we have here a parenthesis, it means this is multiplication. So 20 times 5, that is equal to 100. And 107 minus 100, that is equal to 7. So it means the first term of our sequence is 7. Let's have our sixth example. For the sequence 2, 6, 10, and so on, what term has the value of 106? Dito naman, hinahanap natin yung bilang ng term or yung n. Ibig sabihin, pang ilang term ang 106. So let's try to have the given. Ang a sub n natin ay 106. O ito ang ating pinaka-n term or yung last term natin. Pero hindi natin alam kung ano yung value ng n. Ang a sub 1 natin ay 2 since ito ang unang term natin. And d naman ay 4. So para makuha ulit yun, second term minus first term or third term minus second term. So that is 6 minus 2 equals 4. Then, since wala tayong n, yun ang hahanapin natin dahil hindi natin alam kung pang ilan ang 106. So with the use of this formula, n is equal to a sub n minus a sub 1 all over d plus 1, we can easily solve the value of n. Then next, by means of substitution, a sub n is 106, a sub 1 is 2, and then d is 4, and by simplifying, 106 minus 2, that is equal to 104, then bring down 4, same with 1, 104 divided by 4, that is equal to 26, and 26 plus 1, that is equal to 27. So here, it means the value of n is 27, or 106 is our 27th term. Let's have our last example. In the arithmetic sequence 5, 11, 17, and so on, which term is 395? Ibig sabihin, pang ilang term ang 395? So, una nating gagawin, i-identify natin ang mga given, which is a sub n is equal to 395, a sub 1 is 5, or ang ating first term, and ang d natin ay 11 minus 5, which is equal to 6, or second term minus first term, and ang n natin na nawawala dahil hindi natin alam kung pang ilang term ang 395. With the use of the formula, n is equal to a sub n minus a sub 1 divided by d plus 1, kagaya ng ginamit natin dun sa last example kanina, masosolve natin ang value ng n. By simply substitution, ang value ng a sub n ay 395, a sub 1 ay 5, d ay 6. So by simplifying, 395 minus 5, that is equal to 390. Bring down 6, same with 1, and 390 divided by 6, that is equal to 65, plus 1, that is equal to 66. So it means 395 is our 66th term of the sequence.